not easy to attend this lecture in this early morning. Sorry about that. To bring you today here. I will give you two lectures today, the lecture 12 and 13. Then tomorrow I will have a last lecture, only one. And today the lecture topic about the composite material application for various industries. The aerospace engineering, and industrial applications, and automotive applications. Those about, and the rest of industrial application, it will be talked in the next lecture. So a new generation composite application means it's the most important keyword is weight. All kinds of composite materials can provide the benefits of weight saving. It's a very basic one. But even in the case those are not losing any stiffness or strength. And in order to that, have best the design, the satisfaction, we can design its anisotropic top as we wish. So we can remove any stiffening along the directions where we don't want to have a high stiffness, high strength, something like that. So those three different kinds of advantages are basic keywords for all kinds of composite materials. So it can be summarized like this, offering unparalleled strength, weight saving, and design flexibility. It's based on those three characteristics. So here we'll explore the next generation composite application. So we start from aerospace application because it is first use, usually first use with advanced technologies, not just the material sector, but also all of very sophisticated, newly developed one. If those are very reliable, then regardless of the cost, all of new generation technologies can be used for aerospace. So that's why all of advanced technologies can be found in aerospace application first. So then that doesn't mean automotive application is less technical, less advanced technique compared to aerospace. So I think the extension to the automotive application after aerospace application has more meaningful, because aerospace application case, so it is not considered for mass production, because the number of required structures are limited. But automotive application case, mass production must be engaged. That means advanced technology is fully developed, and the cost can be lowered by mass production. So the application to the automotive engineering is very important to our daily life, I think. So aerospace application, so of course we are enjoying the lightweight structure and aircraft interior, advanced wings, fuselage impingement. those kind of things. So lightweight structure is the main body. Right? So it's ultra lightweight airframe is the example. And the aircraft interiors, the durability, design freedom, and weight savings. So usually we say this lightweight structure, ultra lightweight airframe, something like that, we say this is a primary structure. That means the structure must support very highly loaded the environment. But the other things, this interior ones, this we say is a secondary structure. Secondary structure means it not so high loading is considered. Okay? So that means it's just a durability or design issue, weight saving, those are important in this case. Okay? And advanced wings is important of course. But relatively to the primary structure, this advanced wings has smaller surface area. Okay? So, but it requires complex geometry. But as you see, the composite material manufacturing process, because mostly made by manual method, that means complex geometry can be the necessity. It can be embodied through this. Okay? So complex geometry and the integrated system characteristic is possible for the advanced wings by composite materials. And fuselage is also it's a lighter and more durable characteristic is the possible from composite material, and currently those are being built and used. And the infinite is a stability and the precision. It can be satisfied through composite materials. So firstly, lightweight structure, primary structure for aerospace engineering is first as a high strength to weight ratio is important. So this kind of key issues is important when you choose composite system for use in design process. So composite material offer exceptional strength while being significantly lighter than traditional metals like aluminum alloy. And secondly, the tailored design can be found through advanced composite materials. So composite can be engineered with precise fiber orientation. That means unneeded, unwanted directional the directional stiffness strength can be removed intentionally. So it can provide the more weight saving. So we can optimize the strength and weight for primary structure. And also this is the outermost surface used. So corrosion resistance is very important issue. So as you see, the composite material is also very strong against corrosion. So this is also the main point to be chosen for this. So this is a sample of the currently used the composite materials in aerospace application. This is secondary, okay? Seating, and this storage part inside the cabin and the cabin interiors. Okay? All of those used by composite materials these days. Okay? And advanced wings, so the important points aerodynamic efficiency, integrated system, structural integrity. So of course this wing must require complex optimized shape. So that's manufacturing the process must be considered to make this possible. and the integrated system. So composite wings allow for the seamless integration of control surface, sensor, and other systems. And the structural integrity, it is very easy to embody strength and durability for aircraft wing, and improving safety and reliability. Okay. And whereas for automotive application, so the current composite material application for airplane or space shuttle, it's a long story already. So it's going back to 1950s, and mostly developed in 1960s. But it comes to the automotives, it just maybe going back to 1990s and most. So even these days, after 2010, these days are gradually increasing the number of applications for automotives. So most difficulty issue about that, of course, the difficulty of automatic manufacturing process for composite materials. There's only that can be the guaranteed. The automotive component or body can be used, because automotive means it does not manufacture just less than 100 units, something like that. It needs at least millions, 10 millions, something like that, per unit component. So that means manufacturing issue must be considered for automotive application. That is a different point compared to aerospace application. So body panel is body panel. As the purpose is the same as the airplane, aerospace industry is. So body panel is must. It is used because it's lightweight, and in a little bit more important emphasis for automotive compared to the aerospace is impact resistant, because airplane case is a very small number of opportunities to be impacted. But the automotives means it is daily using one. So means there are many accidents. So we must think there are many small and big impacts from exterior. So the final products of body, this is the exterior surface. It must be considered to have impact resistant material. Otherwise, it cannot be used. Right? And the customizable body panel. So because as you see that these days car is very beautiful outer design, and very curved surface, very complicated. The very small part of design also can be found easily. So that means it must be the customized as needed. And the chassis component case, differently from the body panel, the size of components is relatively small. That means RTM can be used easily. RTM is one of the well-established manufacturing process for composite materials. So this so part of chassis components and some other small the auxiliary components is possible through RTM or its variations. And its emphasis point for use is must be about superior strength and stiffness and weight saving. So the weight saving is a very common issue for whenever we choose composite materials for raw material. But in this case, the superior strength is different from body panels. The body panels, although it is the primary one, but the automotive structure case, the main load bearing part should be chassis. So chassis must have a superior strength over a body. And the stiffness also very important, because it's a large deformation cannot be expected for automotive use. And recently the EV is very popular and very common, although these days are a little bit chasm of EV, but the number of EVs will be increasing continuously. And in the case of the EV issue is usually the battery protection. The battery can be very dangerous against any mechanical impact and any very hot temperature environment. So usually before without fire accident, the battery to keep its optimal performance, thermal management is very important, right? Because in the case, if the operating temperature, the ambient temperature of a battery is changing, the performance of a battery severely influenced. That means casing is very important in that sense. So the protection against mechanical impact, and it must be good for thermal management. So that means insulation is very important. Right? And to secure to take more space for battery cells, design case design, the shape must be flexible. About the body panel, it's a lightweight, impact resistant, and customization. As we saw the previous slide, so those are important. So this is a common emphasis. And impact resistance, because this body panel is installed utmost of automotive. So it must be impact resistant to external incoming object. And the customization is for design issue. Okay? And a chassis component is exceptional strength is required, and improved stiffness is required. Exceptional strength is to transfer the load very well. It is needed due to that point. Improved stiffness, the large deformation doesn't want to. It is not wanted. It is not wanted because the stiffness, the chassis was very robust and strong. Okay? So improved stiffness is kind of the Young's modulus or something like that. So it's made very important for chassis components. Okay? And our weight saving is also important, even for conventional vehicles, because the power per unit, the weight should be high. It is mandatorily necessitated to be survivable on market, because in the case the fuel efficiency can be enjoyed. Right? And the EV case, EV battery enclosure is most important issue. Right? So EV battery, thermal management, structural integrity, and design flexibility. Three of those. And the thermal management is must find the characteristic of effective thermal insulation characteristic and cooling, the integrated cooling system made from the composite materials chosen, so that it can optimize battery performance inside. And the structural integrity issue is regarding exceptional strength and resistivity points. So this kind of highlighted points should be basis to choose a composite system for automotive. Of course, all of composites in design pool for automotive. It must be possible, very easier or very effective for mass production. Without mass productability, it cannot be considered for automotive use. That is very different point from the aerospace application. And this composite body panel this improved aerodynamic and weight reduction. So this is the airplane, the head part, and the streamlined design, weight saving, corrosion resistance, and customization. So considered and streamlined designs mold into complex aerodynamic shape. It's mandatorily needed, right? It's so that it can so make very high speed traveling in the air, right? And the overall weight should be very small, and of course the long-lasting performance is very important, because differently from automotives, it's the lifetime should be very long, longer than decades. But automotive case mostly within decades. And the composite chassis component, so it's used to enhance durability and crash protection. The crash resistance is needed to absorb and dissipate impact force. So aramid fibers reinforced composites, especially have high the impact resistance material. And structural integrity is more robust, and the durability issue should be satisfied. And EV case, thermal management safety means thermal regulation and the impact protection and weight optimization. These three issues will be design points and currently being used based on these the point satisfaction. And thermal regulation means a composite battery includes incorporate advanced thermal management system, so as to maintain optimal operating temperature and prevent overheating. The impact protection, the high strength of composite ensure the battery includes that it can withstand significant impact and collision, safeguarding the critical components. And the weight optimization is a lightweight composite material help minimize the overweight of battery system. So many students they just think maybe the electric vehicle is lighter than traditional vehicle. They think like that, but opposite, right? Opposite. So because electric vehicle is much heavier than traditional vehicle. Electrical vehicle must have larger contact area, tire, wheel, compared to conventional ones. It is not due to the body weight. It is due to weight of batteries. Battery very, very heavy, and to cover up to 500 kilometers per full charge condition, the battery weight itself is already 300 kg, 400 kg, so that they wanted to use aluminum alloy for body to reduce overall weight. Okay? That's why electric vehicle have many aluminum alloy component and bodies compared to traditional ones. Traditional ones, high strength steel plate is needed to use usually. So whenever possible, the electric vehicle, they wanted to get much weight saving. So composite material is one of the best choices. But cost is problem. Still, cost is problem. And the manufacturing process for composite component is an automotive lathe ATL system. You heard the last lecture. And the molding techniques and the curing finish quality inspection. For automotive use, this must be automated. Otherwise, mass production is not possible. It's not possible. So, this manufacturing process for automotive composites. As injection molding is mostly used, and compression molding is also used for large body structure, and RTM, and automate the fiber placement is AFP, automatic machine. Those are already developed and can be found on markets. But in the last lecture, maybe I did not talk about compression molding. So compression molding is very simple one, so I just add one more slide here. For manufacturing technique for composite materials. This compression is like the conventional press compression machine. It's the same. But in this case, it is not used for metal raw material. In this case, we are talking about composite panel. It should be the body must be heated before placing between compressed mold. So curing oven, so this is a heat schedule that's needed before pressing. Because the ambient temperature is not good temperature for making permanent shape change in composite panel. So it must be heated by using some heat schedule. So that means it will be pressed as a final shape. That means that in this case, this matrix should be thermoplastic case only. Only in that case it can be compression molding method can be used. So thermoplastic PMC plate will be used for this purpose. And the quality control and testing for composite structure as material testing, structural evaluation, environment testing is being engaged. And environment testing, this is the needed for composite material part. It's different from the metal part for conventional vehicle compartments, because this composite material is a matrix. It means the binding material. It's a plastic mostly. Plastic is humidity absorbing and UV light influenced, so its property can be degraded sooner or later. So it should be tested and outside, and in some very designated environment must be tested. It is different issue compared to metal components of conventional components. And the maintenance and repair composite aerospace parts. So inspection is visual and NDT usually is needed. So steel case, because it has very good ductility, its plastic behavior after deformation is guaranteed. So its toughness is well enjoyed already. So there is no issue about that. But composite material case, it can be fractured, sometimes brittle. So damage distribution is very concerned. So non-destructive inspection technique is very, very important in composite material manufacturers. So all of composite material manufacturers, for final use, they must have a very expensive NDT equipment. There is no other. Just the visual inspection is primary. It is not sufficient for inspection. And the damage distribution status must be checked before sending it out to the market. And the repair technique is very complicated and important issue. So metal case is very easy to repair because it can be reworked plastically, and it can be welded if needed easily. But composite material case, it is not possible. Welding, it is not possible. And if there is some laminate inside, partially damaged or delaminated, then how it can be fixed? It's very difficult issue. So repairment of composite panel is a special technique to entrepreneur. So that kind of fixing repair technique is going to, it should be asked to very specialized industry, not by workshop easily. Because although it can be the bonded again, for example, by yourself to repair some the detectable damage, but if you check it very microscopically, then the stiffness or strength have not been repaired, has not been recovered completely. So you cannot believe after very simple bonding by yourself. It must be asked to specialized company. Okay, must get specialist advice. Otherwise, you may get final catastrophic failure. Means death. So it's very important. Right? And so a repair technique is one of a very good business point. You can think about this. How rather than manufacturing, I repeatedly said up to this lecture, composite materials in the sense of mass use in community is the beginning stage. Although it has been introduced into industrial structure more than 50 years ago, but it is just for small number of applications. But recently, the mass use of mass production based components or parts with composite materials are just the beginning stage. So all kinds of related business now being founded. So you can participate in those kind of technical business chances. So if you get any composite design part or the reinforcement or matrix parts or manufacturing parts or repair parts, any kinds of parts related to composite material. So there are tremendously many opportunities you can start your business. But based on the terminology used in this society, in this community, must be educated by yourself or through any kind of education, so that you can communicate with the specialist in the community. Because that kind of participation is very important, because every day new idea and new trial and new patents are being developed and introduced. So there are so many variations, not so difficult, but most time consuming and cost consuming. So you should choose one of the good ones too. The repair technique is one of those. Okay? So the repair methods such as patching, bonding, reinforcement, those kind of is one of the issues. And preventive maintenance. This is a proper maintenance protocol. Also, this is well trained. This must be conducted daily or weekly, in regular manner. The cleaning, lubrication, protective coating. This can help to extend the service life of composite material. And the sustainability and the recycling of composite material. So material recovery issue. So innovative recycling process. The recycling, this will be treated tomorrow at the last lecture. But the material recovery is one of very important issue these days. This is mandatorily necessitated by government policy in many countries. So although it's more costly and more troublesome to composite material manufacturers, but it cannot be avoided. It should be practiced. Right? Innovative recycling processes are being developed due to policy issue and eco-friendly or zero carbon dioxide issue, many kinds of things. And being developed to recover and use valuable fiber and resin from the composite part. And repurposing is used differently. Right? So composite material can be reclaimed, repurposed for a variety of applications. So as we wanted to get waste reduced and sustainability promoted. And the closed loop manufacturing is the issue which we treat tomorrow. But any closed loop manufacturing is one of the common the manufacturing issue, the full life the loop for any kinds of industrial product. These days they consider recycling from the design stage. And sustainable manufacturing, as a composite can be produced using renewable recycled material, reducing environmental impact. And the end of life recycling, improved efficiency, those will be treated tomorrow. Right? And the automotive industry trends and challenges is lightweight construction, sustainability, and customization, structural integrity, and design flexibility. So those are the important to engineers and operators. So lightweight construction is especially for small and large scale mobilities. So every kind of mobilities that require this kind of advantage. And the sustainability, so automaker under pressure to use more environmentally friendly material. So otherwise they cannot sell their vehicles. So it should be accepted as by the authorities or by the consumer groups. If any manufacturer gets a bad reputation about this, to violate sustainability or against the eco-friendly environment issue. In the case of that manufacturer, it's difficult to survive in market. So although it is costly, but it's willing to accept those kind of mission. Okay. So composite material also not exempt from that issue. And the customization is various design, different design and the design variation is accepted by users. The final consumers these days, they request a very unique color or unique shape sometimes, whenever it's possible. So manufacturers may be able to offer those kind of various options from final users. So composite material manufacturing engineer must think those kind of flexibility too. And the structural integrity. And the composite can be engineered to provide exceptional strength and rigidity and meeting safety standards. It's well understood. And the design flexibility is a composite or complex organic shape cannot be achieved with traditional manufacturing. So, one of misconceptions based on new materials. So conventional manufacturers, traditional manufacturers, if they want to get, okay, so weight saving is needed, although it is a little bit more costly. But many times they do not understand the manufacturing step should be very changed, even for monolithic cases. If that component changes from metal to ceramics, for example, except composite material case. Even in the case, the shape of the component, they just think that shape of component is just kept same as metal or ceramic. But processing method is different for metal and for ceramics. One is just die casting or just a conventional casting and casting. There are many conventional ways to manufacture metal components. But if you adopt the ceramics, in that case, those kind of manufacturing technique will not be used any longer. Right? That's different. That means there's no casing. I mean, no mold. Right? It's kind of a CVD, some different technical method will be applied. That means the shape can be changed. Final shape. For example, if it was not easy to satisfy design requirement based on metal due to its manufacturing process. In the past, maybe because of processing technique, that design shape must be accepted. But if they change material to others and the manufacturing method is changed, then that unnecessary design part can be omitted or changed. It does not need to be kept at the same shape. Right? Not just weight saving, the design requirement should be investigated. If you change material for the same component. So composite material case is also considered for the better case, because monolithic materials does not provide anisotropic design. But based on composite materials, you can intentionally design on isotropic characteristics. So you could the stiffening only direction you want to do. If any direction has no strength needed, then you can neglect the stiffening for that direction. That means design flexibility much vastly better to the case of composite material. So you must think those kind of issues. The design flexibility is not just for the basic area. It must be think in advanced way. And this is a real case study. The real world composite automotive applications are already being used. The lightweight race cars, maybe Formula 1 racing, something like that. Based on the same engine power, if you get very light outer body, in the case the competitiveness should be enhanced. So lightweight race cars can be found already. By using composite materials, you can enable ultra lightweight, high performance vehicle as final shape. Already these kind of things are used. And efficient electric vehicles, by using composite materials, you can maximize the range and the efficiency of vehicles, especially the battery case, as I said. And premium automotive design is possible from composite materials. In the case, body painting is not needed, because body painting needed for the cover, the base color. But the metal case is needed. But engineering plastic, so all of color is already decided. Right? So painting job is not needed. And the future composite in automotive industries, so they are consider increased adoption of composite materials, because it can guarantee wide range of automotive function. And innovative manufacturing, they are thinking, because mass production must be possible to use composite materials. Otherwise, mass production capability, composite material cannot be used. But the performance of composite materials already proven through aerospace industries. So to get weight saving and higher strength, that means higher specific strength through composite materials. So many of automakers, they want to use composite components these days, but they must resolve how make it automated manufacturing technique. Otherwise, mass production is not possible. So innovative manufacturing is every day, always they are practicing and developing for application of composite material into automotives. And the sustainability focus. So metal case, the recycling is well established, but composite materials is not well established yet, but it is mandatorily required by authorities. So sustainability focus is very important issue for composite material components. Otherwise, they will get bad reputation against eco-friendly environment. So those are considered by the industry.